Welcome back. So we're going to pick up where we left off, and we're in Module 8, and this is which video? We're in the third video now. And in this third video, we're going to dig deeper into functions. Now, much of what I'm going to cover is not something I'm going to hold you accountable for. And I'll let you know what's important, and then there'll be more that it's something that, depending on the pathway you're on, what courses you're going to take next, could be very important for you moving forward, or it could be something you'll never use again. Okay. So like I said, this is a digging deeper, and much of what I'm going to cover in this video is not going to be something that I'm hold you accountable for, with the exception of the things I do say, hey, this is important. Okay. So with that said, let's pick up where we just about ended the last video. And I apologize, I ended the last video briefly, or abruptly I should say. Ended up had to get a glass of water, and let's come back and we'll talk about this function, buggy. And buggy receives an argument if we pass the argument to it, and we see here in this cell, if we call the buggy function, we pass it the argument a. It comes in, and we've got a parameter called arg, A-R-G. Now, it's not a reserved word per se, but it's something that we traditionally use with functions to represent a single argument. So, with that said, if we mouse over it, it'll tell us that's a parameter. What can go in it? Anything, whatever you want to put in it, depending on if it aligns with the context of what it's being used for. Now, result, like I said, that's persistent, and we'll go ahead and print what's in result. We'll see it there. And if we ran it again, what's in result would have persisted. The A would still be there, and you would get A and B the next go. Now this next one, we have that argument that's passed. Result is not persistent. It only exists within the function. And we append that argument to it, return the result, where we call this works function. And it only returns what's in there at that point in time, because when we go to run it again, it overwrites whatever was previously there and zeroes it out, if you will. So with that said, if we said result equals none, it's the same kind of thing. Result is none. There's nothing in it. If result is empty, we're going to go ahead and make it into a list. Append whatever was passed in, what argument was passed in. So we take this parameter, we append it to that list, and print it. Now at this point, that list has in it whatever you passed it. That's the A. Okay. Now, if we call non-buggy in this print function, it runs the function, executes it. We call it, it runs. That's the first thing we see. And then this print function gets back. Does this function return anything? No, there is no return line. So since nothing comes back, we see none. Same thing, twice in a row, it's not persistent. So ARG will receive an argument. The asterisk, and The asterisk itself, we look at that as a wild card. In many languages, when you see an asterisk, that means wild card. And it means from that point forward. In this context, what it means is we're going to receive multiple arguments. So we say asterisk ARGS, plural, because we're receiving multiple arguments. And what that essentially means is, if there are a grouping of arguments, and I'm going to come down here and show you the code, we invoke, or we call this function, print args, and we pass it 1, 2, 3, 4, 5 arguments. We pass it 5 arguments. It received them, and it tucked them all nicely away into one object. Now that object that it stored them in is a tuple. And we think back, tuples, they're immutable. You can't change what's in them. But we can access what's in them if we need. So think of it as if we just sent a package of arguments all in one little package. That asterisk wildcard args. We said print it, or execute that, call that function. It then prints string literal constant followed by whatever's in that tuple. Okay? So that asterisk right there says bring in these arguments all together, wrap them up into a tuple. And then when we get in here, we don't need the asterisk anymore because it's saved into args as a tuple. And then we go to print it off, it says positional tuple. Now, at this point, nothing was passed to it. We see the parentheses there. Parentheses indicates tuple. If we called it and actually passed it stuff, it will then return the tuple, everything that we'd passed it, separated by commas. Remember, tuples are separated by commas. Now, we can pass one argument, we can pass a grouping of arguments. I can pass individual arguments. Here in this example, they passed a couple of individual arguments positionally, and then whatever is passed beyond that. So how many arguments can we pass this function? Well, at least 2, or do we have to pass it 3? Let's assume at this point we have to pass it 3. It receives the 3 of them. And if we passed it cap, gloves, scarf, monocle, mustache wax, the first 2 get tucked into those positional parameters. The last 3 ended up in the tuple. Now, what will happen if, I'll go ahead and run that. What will happen if we pass it 2? It requires 3. It requires 3, but essentially what's happening, it brought those first 2 in, and then this one, by having that there, it said, hey, anything beyond those 2, just tuck it into that tuple. Well, there was nothing beyond those two. So we've got that empty tuple. This kind of goes back and piggybacks off of what we had previously. Right here. Same concept. Okay. So this is not something we're going to use in this class per se, but you may see these concepts in a class beyond the scope of this one, and you may see them in projects that may come up somewhere. And at least now you understand what args, asterisk args. And now let's talk about keyword args, or KW args. Keyword args has two asterisks. And essentially what this means is that it works like args, but instead of bringing in just one thing and putting it in a tuple separated by a comma, and then the next thing, and the next thing, and the next thing, keyword args brings the stuff in much like a dictionary. So let's treat this as if we define the function here. We're using keyword args, and we say, all right, let's print off keyword args followed by whatever came in keyword args. Well, here we invoked it, and we passed it a keyword value, keyword value, keyword value. Well, this looks a lot like we were defining a dictionary. It really looks a lot like we're defining a dictionary. And if we print keyword args, we get an empty dictionary. So essentially, if we use this keyword args, it's going to create a dictionary for us. And here's an example of it actually working. Keyword value, keyword value, keyword value. So if we used the other examples, they're tuples. This one, it's a dictionary of sorts. Okay? So what if we had only keywords? And in this example, we pass a parameter, or we pass an argument to this parameter data. And I'm not thrilled with the way they've worded this, because they're naming the parameter the exact same thing as what it is, but we've got name and value. So data, okay. And if I say print data, well, we're passing data to it. And data came in. For value in data, start to end. Now you remember what this is. This is a slice from 0 to 100. So we've got our 0 here. Start was defined. End was defined, the default values. Had I passed a value, I could change whatever goes in there. And we essentially just slice that list. And for each value in the list, print the value. Now, what if this was not named data? Would this still work? See, it doesn't have to be named the same. What do we call this right here? Well, this is a list. There's the name, list. What do we call it right here? That's the argument we're passing to print data. What do we call this right here? Now, when I mouse over it, it says list, data, 6 items. That's because I've already run it. Now, if I come over here and I clear the output and mouse over it, I shouldn't have set it still. It's my connection, my runtime connection's persisting and it's still holding that data. It remembers what data was. So this data, this is a parameter coming in. Here's the parameter, and then we print a value from that list parameter that was utilized here. We perform the slice by defining in the argument what the value of start is instead of going with a default. Same thing by defining what the end is instead of the default. Okay. So this one little aspect right here is something that is important. This is important. And this is something that you may see in a quiz. You will likely have to deal with this conceptually in a notebook. And when I say deal with it conceptually, we need to understand that when I pass these parameters in, or I pass attributes in. So let's walk through this. And this is one of those things where we try to figure out where does this value exist and where does the change exist. So this right here, and it depends on what kind of variable we're talking about. If I pass an integer to a function, I pass the value. If I pass a list or an array to a function, I don't pass the value, I pass the reference. It's like, well, wait a minute, what do you mean pass the reference? I'm not actually passing like I'm handing somebody money. I'm handing somebody the location of my money should they need it. And if we think of it that way, it's like saying, all right, there's this box and we're going to call it outside. And in it are these three words. What kind of data is this? It's a list. So I define this function called mangle. It's going to receive one argument. And in the function, it takes that argument and looks at index 1 and assigns the value terrible to that index. That's something we can do with a list, but I can't do that with a tuple. So we come over here and we say, all right, let's print what outside is. Well, outside, that's a list. And we say we want to pass that list to this function. It goes and gets it, sees what's in it, and then prints it for us. That makes sense. I called the function, I passed it the reference. It went and got what it needed and did the work. So we think about that example I gave before about I need to get my car painted. He said, well, I need your car. Here's the keys, it's right around the corner. Okay, that's what we're talking about here. I'm not actually giving him the car. I'm saying, hey, the car's around the corner, the car's over there. So I'm referencing where it is. I'm giving them the reference to how to get it. This next statement we call the mangle function, and we pass it that list. The argument is how to go get what's in that list. We come down here, how to go get what's in that list at index 1. Terrible. How to go get it? Since we know where it's at and we're not working with a copy of it, oh, when we change it, it actually changes. So when we do this print outside, yeah, it's not temporary, that's permanent. And you go call outside as many times, or call outside as a print, reference outside as a print statement, and it's going to come up whatever it's been modified to be. Now, here's an example of what can be done to protect what's in that variable outside the function. Protect the original copy. It's something I do quite often. And that is, we'll receive the argument and we bring that reference where to get whatever they're, and then we know what's going to happen. It's going to get past that reference to how to go get that list. Do we know what's going to happen there? Here's the list. Here's how to go get it. Well, wait a minute. Go get what's in that list and store it in here. And then we're going to take this temp variable and we're going to reference index 1 on our temp variable that happens to be a copy of the original, and we assign the value terrible to that first index. Now, when we go run this thing, we print twice. Print outside, mangle it, print outside. And this is something I used when I was creating this. So it didn't change what was in outside because we made our own copy of what it was so we could use it. I want to show you both of these so that you have the understanding that if we're dealing with lists, if we're dealing with things outside, structures outside of the function, you go playing with them and it's the permanent copy. The permanent version. It's not a copy. So if you want to go do something with it and not impact the original at all, make a copy, do what you got to do with it. And that way when you need outside again, the same way it was before you got to it, it's still there the same way. Okay. Now, doc strings, we've dealt with doc strings in the past. And doc strings, in essence, are what we want to display when we reference help associated with a function. So I'm going to emphasize that the function has a name. I can reference that function by name and not necessarily have to call it or invoke it. A function is a class. Just like a string is a class, a list is a class, a tuple is a class, an integer, a float, they're classes of code. And we just make a copy of them. We create an object that inherited all the attributes and functionality associated with that parent class. So when we created a function, there's rules somewhere about what a function is. There's built-in functionality and attributes associated with what makes a function. And every function has the ability to refer to it using help, and it'll go in there and look for things that exist in that function that are defined as doc strings. So if we said help relative to that echo back there, it'll go look in the main where echo is existing and look and see what is echo. Echo is defined as echo, and it receives anything. All right, well, that makes sense. That's what it is. There's no string docs in it, but this thing that we declared here, print if true, it's got this long string doc in there. And we kind of looked at it as, oh, that's just a really long comment. No, it's not. It's comments in a way that tell the user, when I say user, not the end user, but the person, the developers, seeing that code and understands what's taking place in there. It's a way for the developer to get some insight into that function. So you may not know something about a function you're using. You can go call a help function, pass it the name of the function. It'll tell you whatever it can find out. Help, give me some help relative to echo. All right, here's what I got. There's a function called echo and it receives anything. Well, how about give me some help relative to print if true? All right, so we went and looked, we found it relative to the main, and print if true receives thing and check. And it prints the first argument, and we prettied this up. The way we laid that out within those 3 apostrophes, single quotes one after another, front and back, that's the doc string that's being displayed here. So if we wanted whoever's using the function at some point, hey, man, I want to call that function, but I'm not too sure what's going on in there. Help, function name, and it'll come back and it'll tell you what's going on in there. Or you can create your own function and put things in there to tell whoever's using your code what's going on. If you just want to see the doc string itself, you can go in this route. There was none in echo. So this underscore underscore doc underscore underscore will go get what's in that doc string and not give the front end part of it here. You know, it won't do this and won't do this. It'll just give you what's in the doc string. Okay, so the author says functions are first-class citizens, and essentially what that means is they're just like everything else. They're, as I said, they're classes. They have functionality, they have attributes, just like any other class would have them. They may not have the exact same ones, but they have those things. So we can define a function called answer, doesn't receive any arguments, and it'll print the number 42. Call it, there's your 42. We defined a function called run something, and it receives a function. Now wait a minute, it receives a function. Yep, receives a function. Just like we can pass it integers, lists, all these things that we can pass it. Why can't I pass it a function too? It's an object. We can pass it an argument that argument happens to be a function, and I pass that function in. So we had the answer function. I passed it to run something. Run something took it and then executed it. It doesn't know what the name of it is. It essentially is saying, hey, run whatever they give you. Okay. It ran the function we gave it, And boom, there's the number. Now, what if this thing required some arguments? We may dig into that in a little bit. But for now, let's stick with where we're at. And we've used the type function before. Print the type function. Tell me what data type is run something. It's a function, right? Yeah, it's a class function. The way this is written, it doesn't necessarily always work out this way in our code to where it'll print out the word function. That's why I keep saying use the word print and go that route. A reminder, when it comes to these graded notebooks, if comments in white space have points associated with them, make sure you use them. Even if it's comments like this. End of the line. What's happening in that line? It's straightforward. So if there's something that you're being graded on, you know points are associated with it. If you don't use them, the points aren't going to come. So we're going to define a function called add args. And it's going to receive two arguments. We know what data type it is. It's a function. Well, what if we define one called run something with args? We're going to pass it a function and two arguments. And in it, it's going to execute whatever that function is and pass that function the two arguments. This is slick. We're doing multiple things all in one little function. We're outsourcing the work. I got a guy. And if I tell him what I need done and I give him what he needs to do it, he'll go make it happen. That's essentially what's taking place here. It takes that parameter, and since it's in the function, it knows. That's a keyword. arg1, oh, I'm passing it right here. arg2, we know what that is. Func, I don't know what the name of it is, but they'll give it to me, and then that replaces right here. So what comes in is the argument. So the function name is the argument. Once it gets in here, we call it function or func. What we passed in goes into this parameter, and here's the alias, if you will, for whatever we passed it. Okay. We run or call that function, run the code to call that function. We pass it add args. Add args just adds the two things together. So I say, hey, go get add args. There's the name. Here's the two values they're going to need. Name, two values. Name, the values get passed to it. It's straightforward. The same thing that if I did it here, I could do the same thing here. I just had somebody else do it for me. That's what functions, that's what this whole module is about. Outsourcing things. Compartmentalize the tasks. So I can create a function that adds up arguments, it sums them. As long as they're numbers, we should be good. Return sum args. We define another function that receives a function and a bunch of arguments, and then it returns that function with the arguments in it. We do it, we pass it, it returns it, and it returns the result of it. Now, we've got a little bit left in this fourth video, and we're going to talk about inner functions and outer functions. I can declare a function in the declaration of a function, and that function exists within this function. Only exists in here. Can't call it anywhere else. Can we? Let's run this. Add another block of code. See? It won't let me do anything. It says inner's not defined. Inner is a local function. It only exists in here. I can't do anything with it. But what happens is something that we saw before. If you called outer and you pass it a couple of values, one goes into A, the other goes into B. And then we, in there, declared this function inner that only exists in here, that receives two values and adds them and returns the result to where it was called. Okay. What are we returning from outer? Outer will return you the result of inner being passed A and B. Where'd A and B come from? That's these parameters that we received from the arguments you originally passed it. That's where the 11 comes from. So that inner function only exists inside that. It's protected. We can't get to it or see it. I can get to it indirectly. Outer will get me to it, right? That's what happened right here. So similar is what we see right here. It's about the same thing. We pass it an I. Saying came in. We passed saying to the inner. What's inner? Receives a quote, returns this. Whatever it returns is what's returned here. And that's what we see. Okay. Now, we've got inner functions, and they say inner functions can act as a closure. It's kind of like wrapping this thing up and hiding it, protecting it. All right. So nobody can directly call inner 2. Inner 2 is an inner function. It's only local inside Knights 2. So if we wanted to execute inner 2, we have to do it through Knights 2. So it's enclosed in that other one. Now, if I pass some values, I pass ducks to Knights 2, and then store that in A. I pass Hassenpfeffer to Knights 2, and store that in B. What do we have in B? Well, what is A? What data type is it? It's a function. Wait a minute. A is a function. How's A a function? Knights 2, what did it give me? What did it return me? I passed it duck. What did it give me? It gave me the function. Does that function require anything? Nope. Doesn't require any arguments. But saying essentially got put in there before it got returned. Okay. They're both functions. If you want to print what it is, it's going to tell you, hey, print this. There's a function. That's what you're printing. You're printing the function. The entire function, not what's being returned. Let's print A being executed. There you go. Now you're going to get the result. This actually called what we had. All right. got a little bit more. And this is something, we call it lambda. And essentially, a lot of times what we'll have is a function that it just does some work for us. It may be a little easy little task. We pass it some arguments. They come in as parameters. And everything is actually done, all the work, calculations, or whatever there may be, takes place in the return line. So we have, essentially we could have a definition, the name, the parameters, or the arguments, let's say parameters because that's where we're looking at it here. And then the next line would be return func words. Okay, oh, that's just one definition and return, and that's it. Yeah. So with this, we pass it a list and a function name. Well, that's kind of something we've done already. It's not so bad. So if I passed it edit story, I pass it the list, and enliven is a function. Well, here's the function name. Enliven, there's the function. It receives word. Okay. So as long as you have the name and word when you go to run it, you're good. We passed edit story that. Edit story got words. Didn't get word, got words. And the function name. For word in words, there's that loop that we've dealt with before. For each word that's in words, print func. Func is enliven. Enliven word. So print whatever this thing returns you. Thud, meow, thud is. So that's what's being displayed, one index after another. How many lines of code do we have there? We got a few. We got 5, 6 lines of code to do that. 7 if we're calling the call. Oh. Let's do the call and create the equivalent of enliven all in one line. Let's take 3 lines of code and do it all in one. Edit story. Alright, there's our function. It receives an argument stairs. I know what stairs is. Well, wait a minute. Edit story? That exists. So we're calling edit story, passing it stairs. This lambda, think of lambda as a function without a name. We're going to pass it stairs. That gets stairs, words, and a function. So we're going to pass it something going into words. And this is going to be the function now. We're using lambda, which is anonymous, no name. So we're going to create this no name function. It's only quick and easy going to exist here. This no name function lambda, what parameters are we dealing with? Word. Alright, so there's the parameters separated by what's it doing? This. We don't have a name. We called it lambda instead of enliven. What did it receive as a parameter? And then what's it returning? Lambda, parameter, what's it returning? So we did all the work in that return line. We did the whole thing. Declared a function, got some functionality, and called it and passed other things all in one line of code. Now, it's an attempt to be more efficient in lines of code. And sometimes we kind of go over the top when we're trying to be efficient in how much code we write. We've got functions that are generators. They will go do work for us to give us a result. Now, we want to add up the things within the range 1 to 101. Some function adds things, and this function goes from this number to this number. So it's like saying 1, 2, 3, 4, all the way up to 101. Add them up, 50-50. We've got generator functions that in essence, they'll create some sequence for us. So I say I'm going to come up with my own range. There's a default value for each thing, first, last, and step. So you can call me, or you can call it, and I don't need anything from you, and it'll run. Or you can determine what the individual values going into those parameters are. Attributes are going into those parameters. You already know if you're just going to pass one, you need to pass it by keyword. Unless it's the first one. Beyond that, what we're doing in here is we define a variable number, and whatever came in first, if anything, goes to number. If nothing came in, then it's 0. While number is less than last, yield number, number plus equals step. Number plus equals step. We're going to take that number and add that number to itself and whatever the step is. So let's run this thing and see what happens. Well, we get nothing from it. It's not performing anything other than the calculation. It'll tell me if I call it without giving it anything. It tells me what's there. And I said something about that in the previous video. If I run it here, it's going to tell us what the generator object is for X in Ranger. Ranger is an instance of my range from 1 to 5. Print Ranger. Same thing. We just get a pointer to that function. For X in Ranger, print X. Well, there we go. It's convoluted in how this is set up. And it's beyond the scope of what we're going to deal with here. If I say for try again in Ranger, what's Ranger? Right there. This returns a list. Ranger equals the list. It just tells me it's an object. It doesn't tell me much. Print each item in there. For an item in Ranger, print it. There we go. So it's one of those things, one of the biggest hurdles in programming is keeping track of what data type things are. And over time you may find yourself including some reference to the data type in the name of the variable or the object. So it could be Ranger underscore list. Oh, I know Ranger's a list. If I know it's a list, then I have a good idea what I can do with it. If I don't know what data type it is, well, I can programmatically have it tell me what data type it is. We've got comprehensions. This is beyond the scope of what we're covering in this class, right? And as are decorators. Okay. I'm going to go ahead and wrap up this one. Got content in here that, like I said, I include more than we need to cover, so that at a bare minimum, you're at least being exposed to things. So I'll see you in the last one, where we talk about namespaces, scope, and recursion and exceptions. Those we will deal with.